Graph the first 6 terms of each sequence. Clearly label and scale the axes. We're told that a sub n is equal to negative 15 plus n minus 1 by 8. All right, so let's create a table. We're asked for the first 6 terms, so I'll do a table of n versus a sub n. So the first 6 terms would have values 1, or n values 1, 2, 3, 4, 5, and 6. All right, so now we go through the substitution and evaluation. So let's see, we would have negative 15 plus 1 minus 1 by 8. That's 0 times 8 is 0, so this would give me a negative 15. All right, and then if n equals 2, we'd have negative 15 plus 2 minus 1 by 8. 2 minus 1 is 1. 1 times 8 is 8. Negative 15 plus 8 is negative 7. Continuing on, we'd have negative 15 plus 3 minus 1 times 8. 2 times 8 is 16. Negative 15 plus 16 is 1. Next term, negative 15 plus 4 minus 1 by 8. 4 minus 1 is 3. 3 by 8 is 24. Negative 15 plus 24 is 9. Next term, negative 15 plus 5 minus 1 by 8. 5 minus 1 is 4. 4 times 8 is 32. Negative 15 plus 32 is 17. And finally, we have negative 15 plus 6 minus 1 by 8. 6 minus 1 is 5. 5 by 8 is 40. Negative 15 plus 40 is 25. So there are the first 6 terms of the sequence, and now we're asked to graph them. So I will take these and plot them as points on this grid. Notice that I have on my x-axis, my horizontal axis is n, and my vertical axis is a sub n. All right, so we don't use x and y here, or even x and f of x. We use n and a sub n. So I have 1, negative 15, I plot a point. 2, negative 7, I plot a point. 3, 1, 4, 9, 5, 17, and 6, 25. And so we look at those points and we say, well, that looks like a line. Well, we're not dealing with a linear function here. What we're dealing with is what's called an arithmetic sequence. And so we do not connect these because sequences are defined by discrete points rather than a continuous curve. So we do not connect these points. Exercise B, we have a sub n is equal to negative 1 to the n by 4n squared. So again, I'll create a table here. N versus a sub n, and again the first 6 terms. I'll do the work right here. So if n is 1, I'd have negative 1 to the first power, and then I'd have a 4 by 1 square. Negative 1 to the first is negative 1. 1 square is 1, so I have negative 1 times 4 times 1. That's negative 4. 2, I'd have negative 1 to the second by 4 times 2 to the second. Negative 1 to the second power is positive 1. 4. 2 to the second is 4, so I have 1 times 4 times 4, positive 16. 3. Negative 1 to the third by 4 by 3 squared. Negative 1 to the third is negative 1. 3 to the second is 9. So I have negative 1 times 4 times 9, and that's negative 36. Negative 1 to the fourth by 4 squared. Negative 1 to the fourth is positive 1 times 4, and then 4 squared is 16. So 1 times 4 times 16 is positive 64. Negative 1 to the fifth, by 4 by 5 squared. Negative 1 to the fifth is negative 1 times 4. 5 squared is 25, so negative 1 times 4 times 25 is negative 100. And finally, n equals 6. I'd have negative 1 to the 6th times 4 times 6 to the 2nd. So that would be 1 times 4 times 36, which is 144. Plotting the points. So we'd have 1, negative 4, which would be roughly here, 2, 16, 3, negative 36, 4, 64, 5, negative 100, and 6, 144. So notice how this sequence oscillates or alternates between negatives and positives.